Ever wondered why the moon exists, or how it came into being? It's a question that has puzzled stargazers and scientists alike for centuries. The moon, our closest celestial neighbor, is more than just a beautiful fixture in our night sky. It's an integral part of our planet's story, influencing everything from the ebb and flow of our oceans to the rhythm of life itself. The moon's existence is no accident. Its birth is a tale of cosmic proportions, a saga of violence, chaos, and ultimately creation. But how exactly did the moon come into being? What sequence of events led to the formation of this enigmatic celestial body? These are questions that have intrigued and baffled researchers for generations. There are several leading theories that attempt to explain the moon's mysterious birth. Each one presents a different perspective, a unique interpretation of the clues left behind in the moon's geological record. Some suggest the moon was born from the Earth itself, a chunk of our planet flung into space by a cataclysmic event. Others propose that the moon was forged in the fiery aftermath of a colossal collision between Earth and a Mars-sized body. There are even theories that suggest the moon was once a wandering celestial object, captured by Earth's gravity and drawn into a permanent orbit. These theories, while different, all share a common thread. They seek to unravel one of the greatest mysteries in our solar system. Each one is a piece of a larger puzzle, a fragment of an epic cosmic story that spans billions of years and countless light years. As we embark on this journey, we'll delve into the depths of these theories, exploring their origins, their implications, and the evidence that supports them. We'll traverse the vast expanse of cosmic time, from the fiery birth of our solar system to the tranquil beauty of the moonlit night. So are you ready to journey into the unknown, to unravel the enigma that is the moon's birth? Hold tight as we delve into the fascinating journey of the moon's birth. First off, we have the Fission Theory, a theory as old as the moon itself. This theory takes us back to the early 20th century when George Darwin, son of Charles Darwin, first proposed that the moon was once part of the Earth. According to this theory, when Earth was still a molten mass, it began spinning so fast that a portion of it, due to centrifugal force, separated and shot into space. This ejected part eventually cooled down and solidified, becoming what we know today as the moon. A fascinating idea, isn't it? This theory was initially well received because it explained why the moon's composition is so similar to the Earth's outer layer. It also accounted for the moon's proximity to Earth and its synchronous rotation. That is, the moon always presents the same face to Earth. However, like all theories, the Fission Theory has its detractors. Some scientists argue that the Earth could never have spun fast enough to cause such a dramatic separation. Others point out that the moon's iron core is far too small compared to Earth's. If the moon did indeed split from Earth, wouldn't their cores be more similar in size? Moreover, there's the issue of the Pacific Ocean. Some say it's the scar left behind when the moon split from Earth. But geological studies have shown that the Pacific Ocean is less than 200 million years old, while the moon is over 4 billion years old. That's quite a time gap, wouldn't you agree? Despite these criticisms, the Fission Theory has its loyalists. They argue that the Earth could have been spinning fast enough under the right conditions, and that the moon's iron core could have been eroded over time by solar winds. As for the Pacific Ocean, they suggest it could be a second scar from a separate event. As intriguing as the Fission Theory is, it's not the only hypothesis that scientists have come up with. There are other equally fascinating theories that we will delve into next. So, hold on to your curiosity as we journey further into the enigmatic birth of the moon. Next up is the giant impact hypothesis, a theory that involves a celestial collision of epic proportions. Picture this: our young, fiery Earth, still in its infancy, is hurtling through the cosmos. Suddenly, from the depths of the universe, a rogue planet about the size of Mars called Theia barrels into Earth with an unimaginable force. This collision, a cataclysmic event that might have been the end for another planet, instead becomes a crucial chapter in Earth's story. The impact of Theia is so powerful that it essentially blasts a chunk of Earth's crust into space. But rather than dissipating into the void, this debris coalesces, pulled together by gravity, eventually forming our very own moon. The giant impact hypothesis, also known as the Theia impact, came into the limelight in the 1970s. It was William K. Hartman and Donald R. Davis who first proposed this idea, and it was met with both fascination and skepticism. But as time went on, and as more evidence was gathered, this theory started to gain a lot of traction. What makes the giant impact hypothesis more plausible than the fission theory, you ask? Well, it boils down to a few key points. Firstly, the similar composition of the Earth and Moon suggests a common origin. Secondly, the Moon's low iron content implies it was formed from the Earth's crust, not its iron-rich core. And finally, the Moon's backward spin and small size relative to Earth align well with a high-energy impact scenario. Most scientists today consider the giant impact hypothesis the best explanation for the Moon's existence, but it's not without its doubters. Like any good scientific theory, it continues to be tested and challenged. But what if neither of these theories is correct? What other possibilities exist? Stay tuned to find out. The capture theory offers a different perspective, suggesting that the Moon is an alien body. Now let's delve a little deeper into this. The capture theory, first proposed in the late 19th century, suggests that the Moon was formed somewhere else in the galaxy, only to be captured by Earth's gravitational field during its wanderings. Quite the interstellar hitchhiker, wouldn't you say? This theory paints a picture of our Moon as an independent celestial body, roaming the cosmos until it got caught in the gravitational pull of our planet. It's a theory that's as poetic as it is scientific, and it certainly adds an air of mystery to our lunar companion. But let's not get carried away by the romance of it all. The capture theory, like any other, has its strengths and weaknesses. On the plus side, it neatly explains why the Moon's composition differs from that of Earth. If the Moon is indeed an alien body, it would naturally have a different makeup, right? However, the capture theory also faces significant challenges. For one, it's statistically unlikely. The Moon would have had to travel at just the right speed and angle to be captured by Earth's gravity, without either crashing into the planet or bouncing back into space. It's like threading a needle from a mile away. Additionally, this theory struggles to account for the Moon's near-circular orbit. Most captured bodies have highly elliptical orbits, but not our Moon, so it's not without its inconsistencies. Comparatively, the capture theory stands as an outlier. While the fission and giant impact hypotheses suggest a shared history between Earth and the Moon, the capture theory posits that our Moon is a wandering stranger, a guest from another part of the universe. So, we've explored three fascinating theories, but which one holds the truth? The answer is still up there, hidden in the Moon's silvery glow, waiting for us to uncover it. The quest for knowledge continues as we gaze up at our celestial companion, forever urging us to reach for the stars. The birth of the Moon remains a mystery, a puzzle that scientists are still trying to solve. We've journeyed through the labyrinth of theories that attempt to unravel this cosmic enigma. Each one, from the fission theory to the giant impact hypothesis and the capture theory, offers intriguing insights, yet none can claim to be the definitive answer. The fission theory, with its suggestion that the Moon was once part of Earth, spun off into space due to our planet's rapid rotation, is a tantalizing idea. Yet it struggles to explain the Moon's current orbit and composition. The giant impact hypothesis, on the other hand, paints a dramatic picture of a Mars-sized body colliding with the young Earth, creating a debris ring that eventually formed the Moon. This theory aligns well with the Moon's composition and our understanding of the early solar system. Yet there are still inconsistencies that need to be addressed. Then comes the capture theory, the notion that the Moon was a wandering celestial body that was caught in Earth's gravitational pull. This theory, while intriguing, struggles to account for the Moon's similar composition to Earth and its unique orbit. The quest to understand the Moon's origin is far from over. Scientists continue to gather data, refine their models, and push the boundaries of our understanding. The Moon, our closest celestial neighbor, still holds its secrets close. Yet every discovery, every theory brings us one step closer to understanding our place in the cosmos. As we look up at the night sky, we can only marvel at the enigmatic beauty of the Moon and wonder about its birth. One thing is certain: the journey to uncover the truth will be as fascinating as the Moon itself. So, As we continue to gaze at our beautiful satellite, let's remember the words of Carl Sagan. Somewhere, something incredible is waiting to be known. It might just be the secret of the moon's birth.